This time I want to deal with the subject of compositing. A composited image or video is one where two or more instances are merged together to create one instance. It's not something you'll be using often, but if you'll be creating masks, you'll need some knowledge of compositing. With some experimentation, you can achieve some interesting results using the various compositing modes provided by Vegas Pro. Before getting into the subject, it's important that you know the basics of colour theory. Colours that are displayed on digital displays belong to the RGB colour space. RGB is an acronym for red, green and blue, these being the three primary colours. Various mixtures of these primary colours create a wide range of colours. The most common RGB colour space currently has a bit depth of 8 bits. This means that each of the three primary colours can have 256 levels of intensity, resulting in a colour range of almost 17 million colours. Although this is adequate for most purposes, 10-bit depth colour is preferred by professional videographers. This bit depth gives a colour range of over 1 billion colours and is ideally suited for high dynamic range content. I have no experience with 10-bit colour, so I'll deal only with 8-bit colour in this tutorial. Vegas Pro equates the intensity range to between 0 and 1, so as far as Vegas is concerned, 255 equals to 1. When two images are composited, each pixel of one image is compared with the equivalent pixel in the other image. The two pixel colour values are then subject to a mathematical formula determined by the compositing mode. The result of this calculation on all the pixels is the composited image. That's the theory. Now for a bit of maths. Let's consider two of the primary colours, red and green, which I've placed on two tracks. If we refer to the two events as layers, the red event is the blend layer and the green event is the base layer. If we composite these two colours, the resultant colour will depend on the compositing mode used. I'll only deal with the basic modes in this tutorial, one of which is add. Using this mode, it's simply a case of adding the two colour values together. In this case, the math is easy, as the red colour bit value is 1, 0 and 0. The green colour bit value is 0, 1 and 0. Adding these together gives 1, 1 and 0, which is yellow. To demonstrate this, I need to set the compositing mode of the blend layer to add by clicking the compositing mode icon on the track header. If this isn't shown, you have to make it visible by editing the visible button set. First, click the ellipsis on the track header. Click Edit Visible Button Set at the bottom and select the compositing mode checkbox, then click OK. By default, the compositing mode is set to source alpha. This means that the base layer is masked by the blend layer unless the blend layer has some transparency. This can be shown if I reduce the opacity of the red event. I'll now select the Add Compositing mode. The result is yellow, confirming the maths. That's an easy calculation. Something a little trickier is when you have a combination of colours where adding the values comes to more than one. Yellow, as the previous result showed, has a bit value of 1, 1 and 0. If we add this bit value to the red bit value, we get 2, 1 and 0. However, it's not possible to have an intensity value greater than 1, so the result defaults to 1, 1 and 0, which is yellow. Let's look at another mode. Let's try the subtract mode. In this mode, the bit values of the blend layer colour are subtracted from the bit values of the base layer colour. So, subtracting 1, 0, 0 from 0, 1, 0 gives -1, 1, 0. However, we can't have a bit value of less than 0, so the red bit defaults to 0, and the result remains at 0, 1, 0, which is green. Another mode is multiply. Multiplying 1, 0, 0 by 0, 1, 0 gives 0, 0, 0, which equates to black. Here's an interesting one. Two white images, so the colour bit values are 1, 1, 1. If I use the Add Compositing mode, the result should be 2, 2, 2. But anything greater than 1 is invalid, so the colour bit values remain at 1, 1, 1. The same should happen if the composite mode is multiply. 1, 1, 1 multiplied by 1, 1, 1 equals 1, 1, 1. However, if the composite mode is subtract, 1, 1, 1 subtracted from 1, 1, 1 equals 0, 0, 0, which is black. Those examples produce composites that are fairly easy to predict. Each image is filled with pixels of the same color value. By default, all video tracks have a compositing mode of source alpha. As I mentioned in the previous section, this means that because of the hierarchical nature of the track structure, any normal video event on a track directly above another event will mask out that lower event, provided that is that the event on the upper track has no transparency. That masking effect can be seen with this combination of events. The checkerboard event is masked out by the video event. I'll change the compositing mode of the top track to add. To understand what's happening here, we need to consult the maths again. It can be seen that every white square of the checkerboard is visible in the top event, which is the blend event. Conversely, every black square has been masked. The video event contains pixels of many colors. Adding the white bit value, which is 1, 1, 1, to the bit value of the pixels in the video event that correspond to the pixels in the white squares gives pixels value greater or equal to 1. We know from the previous sections that bit values greater than 1 are not allowed, so the bit values of the video event pixels change to 1. So, white squares corresponding to the white squares in the checkerboard are displayed in the video event. Now the black squares. Black has a pixel value of 0, 0, 0. If we add 0 to any bit value of the pixels in the video event, those pixel bit values don't change, so the black squares in the checkerboard are masked and the video shows. Here's another example that's a bit more practical. A normal video event is on the top track and a titles and text event on the bottom track. The compositing mode of the top track is source alpha, so the titles and text event is masked out. I'll now change the compositing mode to multiply. The text is now inlaid with the video event and the background is black. If you try to introduce a colour other than black as a background, that colour will be composited with the colours in the video event. I'll show you what the result is. I'll take a noise texture event and place it underneath the text event. This isn't necessarily the result you want. To correct this, I need to use a feature that I intend to do a tutorial on in the future. I need to make the second track a child of the first track. The parent-child options are accessed by clicking the ellipses on the second track. This has effectively isolated the noise texture event from the compositing mode of the first track. To make the text stand out more, I can add a black outline to it. Using this method, you can have text inlaid with an image or video, with an image or video as the background. It's important to note that applying a compositing mode to a track applies for the whole track. So that's the basics of compositing. It's worthwhile experimenting with the checkerboard and video event combination by switching to other compositing modes. The Vegas Pro Help feature has a good section on compositing, with examples of each of the compositing modes. If you want more information on compositing, it's a good reference guide. Just put compositing in the search field and scroll to the bottom of the page. I hope I've explained the basics well enough to get you started. Thanks for watching. Until the next time, bye for now.